Hello everyone. Today we are going to discuss numerical problem based on potential wheel in quantum mechanics. So the question is, an electron moves in one-dimensional potential of width 8 angstrom and depth 12 electron volt. We are asked to find the number of bound states present. Here, so we can see from question that we have a finite depth potential wheel, okay, and we are asked to find the number of bound state present in the finite depth potential wheel. And we know for finite depth potential wheel we get finite number of bound states, and we are familiar with square wheel potential of finite depth. So let us discuss square wheel potential of finite depth, okay, in brief. Now clear. So the condition is finite depth, okay, so I'm writing over here finite depth. Okay, this is Vx. Now this height is V naught, the depth of the potential, and this is 12 electron volt, and let this be minus A and this be plus A, so that the width is A minus minus A, okay. So this equals twice A, and we have width of 8 angstrom here. So width is twice A equals 8 angstrom. So A equals 4 angstrom. So we can write A equals 4 into 10 to the power minus 10 meter. Okay. Now we have V naught equals 12 electron volt, and we know small a is 1.6 into 10 to the power minus 19 coulomb. So 12 into 1.6 10 to the power minus 19 coulomb, and we have volt. Okay. So coulomb volt is nothing but joule, and we know joule equals kg meter square second power minus 2. So we can write joule as kg meter square second power minus 2. Now let us calculate this. Okay, so 12 into 1.6 exponents minus 19. So this gives us value 1.92 into 10 to the power minus 18, and the unit is kg meter square second power minus 2. Now let us find this. Okay, V naught A square. So I shall be dealing or discussing about this, okay, later. First let us find its value. Okay, so V naught is 1.92 into 10 to the power minus 18, okay, and A is 4 into 10 to the power minus 10 whole square, and the unit is, we have this. Okay, for V naught we have the unit kg meter square second power minus 2, and A is in meter, so we have meter square. So finally we can write kg meter power 4 second power minus 2. So let us find this. Okay, so V naught A square equals 3.072 into 10 to the power minus 37 kg meter power 4 second power minus 2. So we are getting this. Okay. So we have this. Let me erase this. Okay. Now, why we are finding this product V naught A square? Okay. We are finding this because the number of bound states is seen to depend on height V naught and A through the factor V naught A square. I repeat once again, the number of bound states is seen to depend on the height or depth of the potential well and A, okay, through the factor V naught A square. So for that reason, we have calculated V naught A square from the given data in the question. Okay. Now, let n be the number of bound states, and we have a finite potential well, and for finite potential well we get a finite number of bound states. This is to be noted, and the number of bound states, so I'm writing over here, the number of bound states is given by this inequality. Okay, n minus 1 pi by 2 is less than gamma is less than or equal to n pi by 2. Let us call it relation 1. This is a compound inequality. Okay, the number of bound state is given by this compound inequality. Now, in this relation, n is the number of bound states, okay, and gamma is dimensionless parameter, okay, and it is also called the strength parameter of the potential. I repeat once again, gamma is called the strength parameter of the potential, and it is dimensionless. Now, the value of gamma is, so I'm writing, gamma is 2m, m is mass of the particle, okay, V naught A square by h bar square whole power half. Now let us put the value of gamma in this relation and simplify. Okay, so we can write n minus 1 pi by 2 is less than gamma, and gamma is 2m V naught A square by h bar square whole power half is less than or equal to n pi by 2. So this is relation 2. Now we can rewrite this relation 2 in this way. Okay, so let me change ink. N minus 1 pi by 2 is less than 2m V naught A square by h bar square whole power half and next, okay, 2m v naught a square by h bar square whole power half is less than or equal to n pi by 2. Now let us solve this first, okay? Let us solve this. Clear? So taking n minus 1 pi by 2 is less than 2m v naught a square by h bar square whole power half. We want v naught a square on right hand side. Okay, so first we take square on both sides. So I'm writing squaring on both sides. We have n minus 1 whole square pi square by 4 less than 2m v naught a square by h bar square. On taking square on both sides, this sign does not change. Okay, now as I said earlier, we want v naught a square, so we have to eliminate 2m by h bar square. For that, let us multiply. So I'm writing multiplying both sides by h bar square by 2m. So I'm writing n minus 1 whole square pi square h bar square by twice m, and we have 4. And finally, on simplification, okay, we can write this as 8m. Okay, so we have this. This is less than, so we have this twice m v naught a square by h bar square, and we have h bar square by twice m. So twice m, and h bar square cancels. So finally, we are left with v naught a square. So I'm writing this, okay, v naught a square. So we get this. Clear? So we have this. Now again, taking this, okay. So let me change the ink, okay. Taking 2m v naught a square by h bar square power half less than or equal to n pi by 2. Now, as we did earlier, first we take square on both sides, and then we do this, okay. So let us take square. So I'm writing squaring both sides. So we can write twice m v naught a square by h bar square is less than or equal to n square pi square by 4. So this is not going to change, okay. Now again, multiplying both sides by h bar square by twice m. So we can write in this way, okay. H bar square by twice m v naught a square by h bar square is less than or equal to n square pi square h bar square by 4, and we have twice m. So this gives us 8, okay. So I'm writing directly, okay. We have 8m, and this cancels out, and this also cancels out. So finally we get this, okay. Okay, let me we get this, okay. So we have this. Clear? So we can write relation to on putting the value of gamma and simplifying, okay, in this way. Okay, we can write equation 2 in this way. N minus 1. Okay, so we have this n minus 1 whole square pi square h bar square by 8m is less than v naught a square is less than or equal to n square pi square h bar square by 8m. Let us call it relation 3. So we have this. Okay, so let me erase this. So I'm writing over here, okay? We get this n minus 1 whole square pi square h bar square by 8m is less than v naught a square is less than or equal to n square pi square h bar square by 8m. So this is relation number 3. Okay, we have this. So let me erase all this, okay? Now, we know the value of v naught a square. Clear? We know the value of v naught a square. Clear? Now, let us find this, okay? Again, let us find pi square h bar square by 8m, because we have pi square h bar square by 8m in relation 3. So we have pi square and we know h bar is h by twice pi. Okay, so we can write this as h by twice pi whole square divided by 8m, and m is the mass of electron. So you need to note this, okay? So let us find this. So let me write over here, okay, 3.3 10 to the power minus 34. So we have this, okay, h bar is 1.05 into 10 to the power minus 34. So we have this, okay. So pi square, and we have 1.05 into 10 to the power minus 34, and we have whole square divided by 8, and mass of electron is 9.1 10 to the power minus 31. Okay, so we are finding in SI system, so we must note this. Now let us find its value. So we have h bar equals h by twice pi, and this is in joule second. The unit is joule, okay, second. So we must note this also, okay. So the numerator gives the value 1.088 into 10 to the power minus 67. The denominator is 7.28 into 10 to the power minus 30. So let us find it, okay, now. So this gives us value pi square h bar square by 8m equals 1.49 into 10 to the power minus 38, and the unit, let us find its unit, okay. See, we have h bar square, so joule square, second square by kg, and we know joule is kg meter square, okay, second square. So kg square, clear, second square, we have this kg square. Let me write in this way first, okay. So this is kg square meter power 4, and we have second power 4, and we have 1 kg at the denominator, and we have second square, okay, over here. So the unit is kg meter power 4 and second power minus 2. So we get this, okay. So finally, we can write in this way. We want to find the value of n, okay. This is what. Now we know this and we know this, okay. Now let us take, okay, this part of the inequality, because we have v naught a square is less than or equal to n square pi square h bar square by 8m, clear. So we can write this as, this inequality as n minus 1 whole square pi square h bar square by 8m is less than v naught a square, and v naught a square is less than or equal to, okay, n square pi square h bar square by 8m. So in order to find the value of n, we use this, clear. So we know v naught a square, v naught a square is taking this, okay, 3.072 into 10 to the power minus 37, okay, and the unit is kg meter power 4 second power minus 2. Let us take the equality symbol, okay, because we have less than or equal to, so I'm taking equal. and we have n square, and this equals 1.49 into 10 to the power minus 38, and the unit is kg meter power 4 second power minus 2, and the unit cancels out. Okay, so we can write n square equals 3.072 into 10 to the power minus 37 divided by 1.49 into 10 to the power minus 38. So we have this. Okay, now let us find this. So n square is 20.61. Okay, so n is under root 20.61. So we get n equals 4.53, and this is approximately 5. So there are 5 bound states. So we are asked to find the number of bound states. Okay, so there are 5 bound states